No, give me a sec. Okay, thanks. Okay, so let's begin. Okay, so kickstart the session today. Okay, so number one, let me just introduce myself. Okay, I know the screen is a bit blurry. Give me a sec. I'll clean it up in a while. Okay, so just want to say hello to everyone that is here. Okay, happy that everyone managed to tune in. Okay, for those that turned up for the EMF one, didn't expect there to be so many people that day. So there was a very big fiasco about it. Okay, so since I don't think I'll hit 500 today, because the cohort for AMF is usually smaller, okay, but it's a healthy 300. Okay, so very good. So I hope everyone is having a great day. Okay, I don't know whether you guys got paper today or not. Oh yeah, have, right? Chem, right? Okay, yeah, I know. The screen very blurry. I'm gonna zoom in, so don't need to worry. Okay, let me just talk first. My voice more important at the moment. Okay, so as this session goes on, okay, if you have any questions, keep them to the very end. Then during the consultation phase, then I will answer your questions. Okay. Then I already take note of the topics that people have put in. Okay, so I will take a look at them. Okay, and I will go into detail about those. Okay, then so that is the main scope of today. Okay, so I don't think the session will run past 500. If it does, then I would start streaming on YouTube, but I don't think it's necessary lah. Okay, so let's begin for today. So first thing, introduction of myself. Okay, so who am I? My name is Kaiwan. Okay, for those that don't know me, I'm the noisy dude that is on your Telegram overmark channel that has been spamming the past few days for the both maths. Okay, so after tomorrow evening, then you will never hear from me ever again. Okay, because I don't, there's no more math lah, unless so that you never hear from me anymore. Okay, until next year for the next batch. Okay, so my background, I'm a uni student. I'm in year 3 studying mathematics. Okay, so I'm in NTU. Okay, I'm studying mathematics. So I want to be a tutor for the rest of my life. Okay, so that's why I'm doing this. Okay, so I hope that this session will be useful for everyone. Okay, and you will learn some things from me. Okay, for those that have been here for either my crash courses or my previous few free live sessions, I welcome you back. For those that were here with me for the very first time, I hope you enjoy the session. I hope you do learn something for your paper tomorrow. Okay, and also because the course you can hold another 200 people. If you have friends taking AMF, if you know that they need help, feel free to always forward that link to them so that they can have a look at it. Okay, so right now, just to give you some opinions about the paper one. So I got the paper one yesterday at about the evening time. So I took a very, very quick look at it lah. Okay, so I haven't really completed the paper yet because I had school. So I was completing my own school stuff. So just by reading through it, it looks like a pretty easy paper in my personal opinion. Okay, it's easier than the most years that I've seen. Okay, so I don't think there are many difficult topics that came out for the paper one. Okay, so in my professional opinion, I think the paper two will be slightly more difficult than normal. Okay, so not to scare everyone, okay, but just take note of it lah. Okay, and yes, for those that are scared of the bell curve, you shouldn't be too scared, but yes, be wary also that there's a bell curve as well. Okay, so with an easy paper, the bell curve will be more scary. With a more difficult paper, the bell curve will be more skewed up. Okay, so it really depends on what your mathematics level is at. Okay, yes, there is a bell curve. Confirm will have bell curve because there's too many people in the cohort taking AMF. Okay, so okay, so just take note of it lah. Okay, so right now what I'm going to do is that based on the paper one topics, what I'm going to do is a little prediction. So I'm going to tell you like what is what is important to take note for the paper 2 tomorrow. So I won't take up too much of your time. So I'm only going to be doing this for about an hour. Okay, so to give you a bit of content, just give you some important things that are necessary for everything for your papers on tomorrow lah. Okay, so let me say something first. Like, I'm not a guru lah. Okay, I cannot look into the future. I do not know what is coming out tomorrow. Okay, but these are based on predictions. Okay, these are based on whatever I think will come out tomorrow. And if you tune in for my email session, I was about 90% correct, okay, about what came out. So you can see like how good I am lah for the AMF session tomorrow. Okay, so yeah, let's start with the breakdown. So I'll be referring to the document that I put out already. Okay, so yeah, if possible, please don't spam the chat. Thank you. Okay, so let's start. So this is the document that I put out. Okay, so all this is not really important. Okay, so I broke down all the chapters, okay, that for the questions that came out already. Okay, so the document in the chat, I think there's a typo. It wasn't the differentiation question wasn't a maxima minima. It was a stationary point nature question. Okay, so it was my bad. Okay, but these are the main topics that have come out already. Not saying that they won't. Okay, but there is a chance that they might. Okay, for the two people that I'm gonna zoom. Okay, so for the two people that said that yes, bearing and drawing, I know never come out. That's why I say 90%. Okay, okay, that's why I say 90%. Hang on, is it really very well? Okay, never mind. When I start writing, it'll be a lot clearer, so don't need to worry. Okay, this should be a lot clearer. Okay, wait. Where got one square? Where got one square? What square? Okay, don't know what you guys are talking about, but I don't see anything on my screen. Okay, so yeah. Okay, so these are the questions that came out for the paper 1. Okay, so you can just take a look at it during your free time. Okay, before the paper, it's already in the document in the channel. Okay, but the one that I want to focus on is the next few pages. Okay, the ones with all the content. Okay, so this is where I'm going to start writing a little bit more. Okay, and so you don't need to worry if you cannot copy down as fast because I will upload this later. Okay, so let's start. I'll run through every single chapter. Those chapters that of course are more relevant. For those that are already tested, I won't cover anymore. Okay, so just don't worry about it. Okay, yes, I've already sent out the document before. So if it's a bit too blur, okay, because of maybe the printing and whatsoever, you can just take a look at it over there. Okay, so about this part, when I start writing, it should be very clear. So this one don't need to worry. Okay, so let's start. Now, for the quadratic functions chapter, which is chapter 1, there are two main concepts, which is the completing the square and this always positive, always negative questions. So completing the square already came out. So the one that didn't come out was positive and negative. Okay, so whenever we are dealing with a positive or negative question, okay, just take note. Okay, so let me use another color. Okay, so when we are dealing with positive and negative functions, right, you must remember what is the main concept behind this, and this is discriminant. Okay, so this is the b squared minus 4ac. Okay, let me write it in a thicker pen. Okay, so this is under the concepts of discriminant. So discriminant completely didn't come out at all for the paper 1. Okay, so the chances of there being one full question on discriminant is very high. Okay, so this will be one of them. Now, you need to understand what does it mean by always positive and always negative. This means that the discriminant value is less than 0. Okay, just make sure that you remember this concept, okay, and the reasons behind it, okay, because you do need to know. Okay, sometimes, and there was a year that came out a question like this, where they ask you for the conditions of the quadratic equation such that the function can be always positive or always negative. Okay, so I'll give you an example. Okay, so I'll split this solution or split this explanation into two. So the positive, the positive side and the negative side. Okay, so for the positive side, some of the conditions, there are actually two for each. B squared minus 4ac, okay, must be less than 0. This is the universal one. Okay, and the other one, the other condition is your coefficient of a. Okay, because all quadratic functions are tied down to this function, ax squared plus bx plus c equals to 0. The one we're interested in is the a. Okay, so for positive functions, your a must be positive. For negative functions, your a must be negative. Okay, a very simple way to understand this. Okay, it's because of this logic. Okay, if you want the curve to be floating above the x-axis, it needs to be a happy face. This means that your coefficient of x squared needs to be positive. Okay, so if questions ask you for the conditions, these are the two that you need to list up. Okay, so this is only if the question says so. Okay, and also just take note, the word positive is a very scary word. Okay, and it's a word that a lot of people get tricked on. So the word positive. Okay, take note, positive doesn't mean b squared minus 4ac is greater than 0. It just means b squared minus 4ac less than 0. Okay, please remember this. Do not get confused. The word positive just means what the shape of the graph will actually look like. Is it floating above or is it floating below? Don't get tricked by the word positive, because a lot of people see positive, right? First thing they do is they go and assume that it is greater than 0 and then die. Whole question wrong. Okay, so be careful. Okay, so this is a pretty simple concept, so I'll just move on. Okay, next, equations and inequalities. So this is a brand new chapter that completely didn't come out. It ties in with the quadratic function chapter. So this chapter has two main concepts, okay, which is discriminant again. Okay, and the other one is the inequalities portion. Okay, so when we are dealing with the discriminant, okay, just take note that for discriminant, there are two separate cases in total. Okay, so one set is for intersections with the axis. So let me write this in blue. Okay, so this is intersection with the axis. And the other one is when you have a line intersect a curve. Okay, so when we go for the intersections, right, remember that there are 4 different conditions for discriminant. Okay, same thing for the line intersecting a curve. There are 4 conditions. Okay, and 4 different types. Okay, so what are they? B squared minus 4ac greater than 0 equals to 0 less than 0 greater than equals to 0. It repeats the exact same thing for the intersection of curves. A line intersecting a curve, you need to know what they mean, okay, and what they actually refer to. So for the greater than 0, you need to see these 2 keywords, to, real, and this thing. To, real, and equal. No real roots. Okay, and this is just real. Okay, so just take note, real this thing, real equal, real. Okay, so yep, just take note that this is what the things refer to. So if you see these kind of keywords in your exams, this is what you need to write. Okay, and what are the conditions of your discriminant? Okay, so whenever you're solving your equations, right, remember that you always need to put your equations into the form. Okay, so you must leave it in this form. Ax squared plus bx plus c. Now, one tip, okay, this is tip, is to do grouping. Okay, so always group your terms together, your x squared terms together, your x terms together, and your c terms must be grouped together. Okay, such that you do not make any manipulation errors. Okay. Now, same thing for line intersecting curve. Okay, so the same 4 will come back again. Now, the last one may be a little bit more rare than the rest, but it does appear sometimes. So you just need to be careful of the wording of the question. Okay, so when you're going for greater than 0, okay, so greater than 0 means it intersects at 2 points. Okay, this is intersect at 1 point. This is no intersection. Okay, sorry for my bad handwriting. Okay, this is just intersection. Okay, so if you need the picture, okay, so the pictures will actually look like this. Okay, so these are how the main diagrams will actually look like. Okay, so just take note of them. Okay, so these are all the important keywords that we need to look out for. Okay, just remember that whenever you see keywords like this, okay, write them down straight away so that you don't make mistakes. Okay, yes, for just now someone answering, what is it? What happens when the question says that the line meets the curve? The word meets means that you do not know how many intersection points, so therefore the discriminant is greater than equals to 0. Okay, so the word meet is the same thing as intersect. Yes, thank you. Okay, so just take note of this. Okay, it's important now. Okay, because it never come out at all. Now, intersect at one point, in case you've never seen the other form of the word, is tangential. Okay, this is meet also. Okay, so just refer to this. This will be the neater version of it. Okay, so it's basically this table. Yes, I'll be sending these later, so don't need to worry. Okay, so yeah, just take note that these are the main two chunks for the discriminants. Okay, and you need to take note of them. Okay, now next thing that I want to stress, okay, is about a certain question type. Okay, because okay, so let's talk about this certain question type. Question type. Okay, is when they ask you to show. Okay, so there is a there's a very special word that is like, okay, you need to show me why. Okay, you need to show me why a curve would intersect something, or why sorry, you need to show why this particular function has real roots, why this certain function have no real roots. Whenever you see the word show, means they are looking for a proof. Okay, so just be careful. Okay, now take note, whenever you are seeing the word proof, proof means that you cannot assume discriminant. This means what? Okay, I know the question says, ignore them. For those that are seeing the inscribed thing, ignore. Okay, that one not important. Don't care. Okay, for discriminant, right? Okay, when they say the word show, okay, so wait, sorry, I'm losing my train of thought. Yes, okay, so you cannot assume the discriminant. So even though the question states that, okay, let's say for example, explain why this particular equation has no real roots, you cannot state that the b squared minus 4ac is less than 0. Okay, that is something that you cannot do. Okay, you cannot use the question to explain. What you need to do is to find the d. Okay, so you need to find the discriminant. Okay, and then you need to show that the d is either greater than, less than, greater than, equals to. Okay, so it's either one. Okay, it really depends. Okay, so it depends on how you want to phrase your questions. It really depends on how you need to show. Okay, just some tips on how to prove this show part out. In case no one has ever told you before, some of the ways is to complete the square. Okay, so I'll give you a demonstration. So let's say, for example, okay, Reynolds space. Okay, so for example, if the question gives you something like this. Okay, and the question says that you need to explain why this is always greater than 0 or something like that. Let's say the discriminant that you have calculated is this. Okay, so how to explain? This is assuming that x is a real number. Okay, so how to explain? Very simple. Since you know for x plus 2 holding squared, this is greater than equals to 0. Okay, take note, greater than equals, there's an equal sign, because if you sub in x as -2, you can get 0. Okay, so it's greater than equals to 0. Since you know that the x squared portion is greater than 0, okay, so this would imply that x plus 2 holding squared plus 64. So you already have something that you know is greater than or equals to 0. You add in something even more positive, it's going to be strictly greater than 0. It's no longer going to have the equal sign, because even if you sub in x as 2, the value is 64. Okay, so this is how you explain. So you can just give a concluding statement. D is greater than 0, therefore 2 real roots or whatsoever. Okay, so this is one way to explain. Okay, I'll give you another demonstration. Okay, let's say for example, it's this. Okay, so sorry, let me rewrite. Okay, given that x can be any real numbers as well. Okay, so yeah. Okay, so yep. So what we can show as well, same thing for this explanation, we can just state that x minus 3 squared is greater than equals to 0. Okay, then what you know, you put a negative sign in front of a positive number is less than 0. Okay, now okay, must have an equal sign also. Okay, then you put like this. Okay, oh sorry, no equal sign. Okay, so this is just another way to show. It really depends on you. Now, sometimes your quadratic equations will not appear like this, because these are factorized form. I've already done the factorization job. Okay, so yes, you'll get penalized because it's wrong. It's mathematically incorrect. Okay, if you put the equal sign. Okay, so yep, just take note of that. Okay, yeah, I can just show you another example. Sorry, give me a sec. For example, things like this. Okay, so for example, if you're given a question that looks like this, okay, and this is your quadratic that you get, okay, negative 3p squared minus 2p minus 7. One mistake that students make is to sub in values of p. So if you go and say that, oh, you sub in p is negative, sub in p equals to 2 negative, p equals to 3 negative, no, it's wrong. Okay, it's rubbish. So what you're supposed to do is you're supposed to go and complete the square. So when you complete the square, you look something like this. Now, I know that it's very obvious that this is negative, but the correct way to do it, you must assume that your examiners are stupid. So you have to make it very obvious. Okay, so the way to do it is like this: you complete the square, then you prove that the value is officially going to be less than 0. Okay, so just take note of it. Do not do the steps of just substituting numbers in. You will get it wrong. Okay, because they call this a non-generalized proof. It is completely wrong. So please do not do that. Okay. Okay. Very good. So yeah. Okay. So this is done. Okay. Yeah, I took up too much space, but there's another concept which I want to say, which is the inequalities portion. So remember, whenever you are solving for quadratic inequalities, okay, whenever you're solving quadratic inequality questions, okay, take note that you always need to show the curve. Okay, so the curve is important. So sorry, let me just write it down. So the curve is important. Okay, I just want to give you some tips about this quadratic curve. Now, take note. Number one, ax squared plus bx plus c less than 0. Okay, remember that your quadratic equation form, okay, there's a few conditions for this to work. Your coefficient of x squared, let me write here, coefficient of x must be positive. Okay, your coefficient of x must be positive. Okay, it cannot be anything else. So just take note of that. Okay, and another thing, okay, this is a trick that I teach students. Okay, so it depends on whether you want to follow this or not. Okay, there are two types of conditions. Okay, so there are two situations where this thing can happen. So let me just not write the symbol here. Okay, now what happens when this is greater than 0, and what happens when it's less than 0? Okay, I have a rule, I have a general rule or general trick that I teach students, is to imagine you're standing here. Okay, so okay, so imagine that you're, okay, I'll answer your question in a while. Okay, so yeah, okay, so you have to imagine that you're standing there and you look at what direction the arrow is pointing to. because you look at this inequality sign, it is pointing there. So it's inside. You see this inequality arrow? This way. So it's outside. Okay, so this is just one way that I do it. Okay, so just take note of that. Okay, imagine that you're standing at that particular point. Okay, and then you look at where your graph is going to be. We must take note also of the way you write your solutions. Okay, cannot anyhow write. If this is A, okay, no, let's not use A. Let's use P and Q. Okay, for this question is P less than X than Q. Sorry, yes, she correct what? Okay, just be careful, okay? Do not write rubbish. Do not do this. Scene working that looks like this. This is ridiculous. Don't do this. This is wrong. Okay, so just be careful. Make sure that the make sure that the inequalities are correct. Okay, for those that learn this method of doing it this way, plus minus plus, or you draw the like that, anything also can. For me, because I'm more accustomed to shading, so I just shade. Okay, whatever floats your boat. Okay, so let me just put this here. Okay, what questions have I seen just now? Why is it that the coefficient of x must be more than 0? Just remember that this is a standard rule. Okay, we always try our best to always keep the coefficient to be positive. Okay, so yeah. Oh yeah, sorry, writing error. X must be less than P. Thank you. Okay, yeah, thank you. Okay, so for that, can't you do an inverted curve? Yes, you can. You can actually do the inverted way if you want, but you must know how to see lah. Okay, you cannot use this method. You get it wrong. You must use the other way. Okay, so yeah. Okay, wait. Why got so many questions? Give me a sec. Let me answer them. When you draw number line, when you draw the curve of inequalities, you can. It depends on your question. If your question is a linear line, then you draw a linear line. If your question is a quadratic, then you do a quadratic. For regardless of it. Zero. How do you prove the discriminant is more than or less than 0? Wait. You can just more than 0 above the x-axis and less than 0. Yeah, it really depends on you and how you want to explain. This is just my way of doing it. There are many ways of doing it. Okay, so you can be flexible as to whatever way you want to do. Okay, yeah, just don't get confused with the different people answering the different questions. Okay, just be very careful. Most of it are correct. Just be very careful. Okay, so don't anyhow trust what people say. Yeah, just saying. Okay, so yeah, this is the chapter. For those who still got issues with this chapter, later you stay back. You can look for me. Okay, I need to move on. Next is polynomials. Okay, so the next concept that I want to talk about is long division. Okay, the division of polynomials. Okay, so for Shanice, later you go back a bit. I still don't understand the completing the square method. Oh, okay. Why not I re-explain that again? Okay. For the completing the square method, right? Okay, look here. This is the way to explain, okay, as to why the discriminant is greater than 0, less than 0, or whatsoever. You break down the quadratic equation. Okay, so you do it by completing the square. So how I do it is that I first look at this. Okay, any x squared term is confirmed greater than 0. Okay, so I can bet money with you, but confirm all x squared real numbers are going to be greater than 0. Okay, there's no other possible way. Okay, so that's why the first step that we always write is that we write that this squared term is going to be greater than equals to 0. Now, why is there an equal sign? Okay, simple reason is because when x is equals to 2, okay, a negative 2, you're going to get a 0 value. Okay. This is b squared minus 4ac. This is the discriminant. Yeah, so whatever this line here is the discriminant that you get. Okay, and then after that, you need to explain why this whole thing here will be positive. Okay. Okay. Yeah. Could you tell again? Okay, yes. Another thing also, if you are asking me questions, right? If you can, you PM to everyone so everyone can see. So yeah. Okay, never mind. Okay, so for the shading thing, right? Okay, I know I say I will answer question now, but yeah, okay, sorry. But the shading thing, right? Just take note that if it's less than 0, okay, I say first off, this method that I wrote down here, wait, this one here, this thing below here, must follow this condition. If your x squared is negative, right, you cannot use this method. You will get it wrong. Okay, so just take note that if it's less than 0, you'll be under the curve. If it's more than 0, you'll be shaded outside the curve. Okay, and then also, right, it really depends on how your school teach you. Some schools teaches you to draw this number line. Some schools teaches you to draw the arrows. It really depends on you. You can do whatever way you want, as long as it makes sense. Okay, so the plus minus plus is for people that knows that this is positive, or whatsoever. Okay, it really depends on you. If you know about the quadratic curve, then just sketch the quadratic curve. It's the most obvious thing, to be very honest. Okay, so yeah, just take note of that. Okay, yeah, I need to move on. Okay, so yes, the negative curve works, but I don't teach people that because it is confusing as heck. Okay, so don't care about the negative curve. Okay, okay, fine. For those that are interested, negative curves, right? What you do, just throw it out. Okay, this is why. This is how you convert a negative x squared curve into positive, because you can just pull out the negative sign and you can flip the inequality. Okay, that's why condition is to always make the coefficient of x to be greater than 0. You do it this way, you will never go wrong. Okay, sorry, I ran laggy one, but it's true. Okay, just follow this method. Do not think about any other thing. Okay, but of course, for those that already learn whatever way you want, then just follow. Okay, this is for people that are still struggling. Listen to me. Okay, take my word as God. Okay, so polynomials. Okay, we go into long division. Okay, so for long division, right? Okay, for long division, just take note that there are a few things that you need to remember about the chapter. Okay, so we go with fx. This is the main starting equation. So fx is equals to gx qx plus rx. Okay, so you do not need to know what the things are. Okay, so gx is your divisor. Your qx is your quotient. Remainder. Okay. Yeah, I know. It came out already, but it can come out again. Okay, so I'm just going through. There's no problem with me going through it again. Okay, so just take note that long division can just appear again. So this is just a revision. If you don't want to listen to this part, then just ignore. Okay, so yeah. Then how do you write out? Okay, remember that your divisor is outside. Your quotient is inside. Okay, sorry, that's not right. Your function is inside. Your quotient is on top. Your remainder is below. Okay, so this is what you do. Okay, and then also just remember this step. Okay, whenever you have a term here and a term here, okay, what is something that I always ask myself? Give you an example. If there's an x cubed term plus x squared, okay. Casper. Okay, so what you do, right, to ask yourself, x multiplied by what give you x cubed? Okay, so it can be x squared. Okay, just ask yourself this, x multiplied by what give x cubed? Okay, so yeah, this is long division. Okay, the reason why I'm going through long division again, I know one of the parts when came out for it, the reason I'm going through is because of this, solutions of cubic equation. You will need it. Okay, so just take note that for solutions of cubic equations, right, you need long division again, so do not throw long divisions away. Okay, just take note of that. Now, for cubic equations, right, just remember. Okay, for cubic equations, remember that there are two possible types. How you get x minus 2? Oh, it's just, this is example. Yeah. Okay. Synthetic method. Well, I've never heard that word for very long. Yes, you can. But it really depends, I guess. Yeah. Okay. Sorry, moving on. For cubic equations, right? Just take note that there are a few things that you need to remember for cubic. Okay. Let me just start talking about it. Now, for cubic equations, take note that there are always three solutions. I mean, not three solutions. Very bad to say that. Three possible answers. Now, there are a few types that will come out. If you want, you can memorize. If you want. Okay. So one of them will be three beautiful. Okay, I'll explain what the beautiful and the gross means in a while. Okay, there can be one beautiful and two gross. Okay, number three will be three gross. Wait, is that even possible? Yes, no, it's very rare. Okay, never mind, not possible. And the last one is one beautiful and two impossible. Okay, so let me explain what they mean. Okay, so yeah, that's why I say for those that like funny methods, right? Like syntactic or you know what is like inscribed, that kind of thing, right? I suggest don't ask, don't confuse people. Okay, so just ignore. If you have never seen what these people are talking about, completely just ignore them. Okay, don't confuse yourself. Okay, so for three, what I mean by beautiful, right? Not to be disrespectful or what, but it's for the benefit of others also. For beautiful, right? Beautiful, I mean integers, and I mean rational numbers. Okay. Gross, I mean decimals or irrational numbers lah. Impossible, I mean complex. Okay, let me explain what they mean in case you have never seen them before. Now, for beautiful solutions, right, I mean things like x equals to 2. Rational, I mean x equals to half. Decimals, I mean x is equals to 2.31456 da, 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 da. Okay, and for complex, I. Okay, so basically, whenever you're dealing with a cubic equation, the first thing to do, okay, first thing is to type calculator. Okay, when you type your calculator, you do mode 34. So mode, this is for Casio, the FX, what? I don't know what. Mode 34. Okay, for those with the other funny calculators, go and figure out how to do the cubic version. If you know the quadratic, the cubic should be just one button after that. Should be most of the time. Okay, first thing you do is to type the calculator, mode 34. Okay, then you go and see your answers. What kind of answers do you get? Okay, you will get three types of answers. Either all the numbers are very nice, very beautiful, or the second case, you'll get one very nice number, which is a fraction or just a number itself, and the other two will be recurring decimals. Okay, and then for the last one, which is one beautiful, okay, and then the two that is impossible. So, okay, so for the impossible one, right? Okay, just take note that impossible means that it is complex, means you cannot solve. Okay, this means that you will not be able to solve that quadratic equation. So why I mentioned this complex, okay, the main reason is because this is for questions. They talk about no real roots. Okay, so this is where cubic equations can link back into discriminant. Okay, so for example, okay, the questions can say, explain why this cubic equation only has one real solution. This means that one of the answers will be beautiful, the other two will be disgusting. Okay, and you'll be numbers that you cannot solve. Okay, so if you want to show that, what you need to do, go and solve out for the quadratic equation, then go and prove using discriminant that the quadratic equation cannot be solved. Okay, so just take note of that. Okay, so yes, correct. Okay, so yeah, so for decimals, right, just take note how to get the answer out, quadratic formula. Okay, so the negative b plus minus that one. Okay, that's how you get out your gross answers. Okay, just take note also, if you type into your calculator and you see that the numbers are disgusting, don't even bother doing the box. Okay, it is impossible to get the answer out. Okay, you just straight away plug into quadratic formula. Or for those super kiasu type, if you want, just straight away type into just plug into the quadratic formula and you will get all your answers also. So no matter what, quadratic formula works for rational numbers, works for integers, and works for decimals. Okay, so just take note of that. Okay, should not have any problems. Yes, I know for those people have been telling me that yes, I know one of the paper one questions has cubic inside, and I know polynomials come out already, but cubic equations never come out. Okay, I know got one logarithm asks you to form a cubic equation, but they never ask you to solve. Okay, so yeah. Okay, this is just my predictions. Okay, the last one that is the cubic identities. Okay, so this one, let me just talk about it. About cubic identities. Okay, there's two types, sorry. Okay, this is a plus b, a square minus ab plus b square, a cube minus b cube, a minus b, a square plus ab plus b square. Okay, these two identities haven't come out yet. Okay, so just take note that you may be asked to solve. Okay, so let me see. How do we show the decimals as part of the cubic equation? Oh, okay. So no, I think I never continue. Okay, so basically, right, to get out the two gross or the two impossible, you need to do long division. Okay, and get the quadratic function. Okay, so this is how you get it. No, you do not do the x minus, then you'll get it wrong. Okay, what you're supposed to do, right? Use this beautiful answer here and go and do long division. Okay, then you do long division. Okay, so after you do long division, you will get out a quadratic function. Once you get the quadratic function, then you go and do the respective methods. If it's a gross answer, then you do quadratic formula. If it's impossible, then you do explain using discriminant. You get the answer. Okay. And yeah, that's about it. Let me check if my summary notes correct. Yeah, it does. Okay, so just take note of this. Okay, it should not go wrong. Okay. Now, last one. Okay, which is partial fractions. So, can you show an example of how to use the cubic identities? Sure. Okay. Simple question. So, let's say for example. Oh, okay. Why not? I show this. Let me see if I have it. Yeah, there we go. Ta-da! This is the NA AMF 2021 paper. The first question was using cubic identities. So this is an example of a question. Okay, so the question come out like this: x cubed plus 27. Okay, you need to use the identities to open it up, and then you need to show that this number is a product of the two integers. Okay, so when you show it, you just use back the identities, you'll get your answer. Okay, so this is an example of when you will need to use this kind of questions. Usually it's very obvious. The type of questions that need this function. It's always those kind they ask you to factorize something, and both of your terms will be cubic terms. So there'll be numbers that you can cube lah. So my suggestion is to go and memorize that list. Don't need to memorize, but just be aware of those numbers, the cube numbers lah. Like 1 lah, 2 cube is 8, 3 cube is 27, 4 cube is 216. I don't know what number. Okay, whatever. Okay, doesn't really matter. Okay, just need to take note of 125, all those kind of numbers that are cubic. Okay, those are the questions that we need. Okay. Must you take into account of the signs of A and B? Yes, you do. Okay, so like you see, right, for this, right, it really depends on what your number is. Okay, so if you see that it is like the most general case will be x cubed plus 27. So you can see that both numbers are positive. Okay, but sometimes, but very rare, I've never seen it come out before, but like it can be like x power 6 plus, I need a calculator for this. 64. This is also cubic. Okay, so you can do it like x cubed square plus 27. Ooh. 2 cube square. Something like that, okay? It can be anything. Okay, so just take note of that. Okay, so just take note of this x cubed plus 27. If you want reference, NA 2021, paper 2, question 1. Okay, the paper got come out before. The solutions for the 2021 AMAth paper is in the Telegram channel, so you can go and look for it. Okay, it's not true that it rarely comes out, it does come out. Okay, so next, let's move on. Partial fractions. Sorry, I'm taking a lot of time. Partial fractions. Okay, so for partial fractions, right, even though it came out once for the paper 1, I think question 4 or question 5, it came out already. But just a warning, that partial fractions comes out with integration. Okay, so there is a chance that an integration question, starting question, may appear with partial fractions. It's a chance. We do not know. I do not know. I'm not a guru. I do not know. But there is a chance. Okay, so the one that came out was a repeated linear factor. So the other two can come out, okay, which is the linear factor, which is ax plus b, cx plus d, a over ax plus b, cx plus d. Okay, and the other one, which is the non-factorizable one, okay, is ax plus b, x squared plus c squared, a over ax plus b. Okay, so yeah, someone asked for a copy of the 2021 AMAth paper. Yes, it's in the channel. It's in the Telegram channel. Just look for it there. Okay, yeah, the answers confirm correct one is look there. Okay. Okay, so for Nicole, later you stay back and then I show you that one. Okay. So yeah, just take note of this. Okay, it comes out with integration. Okay, so that it may come out. Okay, so just be very careful. If it does, okay, just take note of how to react to them. And also remember that for partial fractions, right, you need to remember to always check if proper or improper. Okay, so you need to always check whether it's the sum proper fraction or an improper fraction. So you must be very careful when it's what. Okay, just take note for improper fractions, right? If the degrees are the same, it's considered as improper. Okay, so for example, if it's x squared plus 4 over x squared plus 9, this is considered as improper. Okay, this is if the degrees are the same. Okay, and when you're dealing with improper fractions, please remember to do long division first. Okay, so this is when long division must come back. Okay, and you need to use them. Okay, so just show you my notes here. Okay, this is a diagram that I always recommend students to remember. So when you start off with partial fractions, okay, split up into proper fractions and improper fractions. Okay, then after that, for improper, please take note that you need to do long division. Okay, so when you do your long division, right, you'll write it out in this way: fx, gx, qx, and rx. Okay, then after that, you must be able to write it out. So fx over gx is the same thing as the quotient over the divisor plus rx. Okay, so just take note of that. Now, for this kind, okay, this will be x squared plus 4 over x squared plus 9. When the degrees are the same, these are considered as improper fractions. Now, I know that the chances of this coming out tomorrow is not high, but it's just in case. Okay. For Charmaine, your question later during the consultation, if you don't mind staying, then you ask me again, then I show you an example. Okay. Yeah, x squared plus 9 over x squared minus 4, yes, it's improper as well, because both of same degree. Okay, even though the denominator can split into x plus 2, x minus 2 lah. Okay, but it's still x squared, so you still need to do long division to solve. Okay. Yep. Okay, so let's move on. Okay, binomial theorem. Okay, so for binomial theorem, this is a fresh chapter, so I just want to take note of some stuff for binomial theorem. Okay, I think for this one I'll just use my notes here because I've already written it down. Okay, so for binomial theorem, right? Just take note that we are always interested in the general r plus 1 term. Okay, so it's the general r plus 1 term. Now, this general r plus 1 term can be found in the formula sheet. Okay, so just take note of that. Okay, so whenever you need that, you can always refer it to that. Okay, in case you do not know where is it, let me just show you an example. I don't have the formula sheet, so give me a second while I pull out a school paper. I'm just gonna put a random school, so I don't really care. Yeah, it's here. Okay, so your formula sheets, the binomial expansion here. If you didn't know, the general r plus 1 term is here. Okay, is contained there. Okay, so yeah. 2 hex, no, that is proper. Yeah. I'm coming to that, the m factorial one. Wait. So this is where you can find the general r plus 1 term. So just in case in exams you completely forgot what it means, it's found at the corner there. Okay, so just take note of that. Sorry, here. Okay, so yeah, so we are looking for the TR term. So this is n choose r, a to the power of n minus r, b to the power of r. Okay, the bracket, if you're not used to this convention of writing, it's the same thing as n choose r. Okay, it's the same thing. Okay. Next, whenever you're dealing with independent term of x, okay, so just take note if the question asks you what is the independent term of x, right? Okay, it refers to x to the power of 0. Okay, so it really refers to x to the power of 0. Okay, yes. Later I can talk about it, so don't need to worry. Okay, yeah. Now, whenever you have x to the power of 0, remember that a tip for binomial questions is to always group your numbers together and to group your terms together. So later I'll demonstrate. Okay, I'll demonstrate right now a question with this skill of grouping the terms together so that you know what I mean. Okay, the next one is the powers of n question. So this is the most difficult type of binomial questions, which is the one right here. Okay, so this particular one here is when your powers of your binomial is no longer known to you. Okay, so it is known that so this is when your binomials are known. Okay, when your powers are not known, so it's a value of n. Okay, so you must know how to do this kind of questions. So right later after I finish these notes, then I will demonstrate the question. Okay, and the last one is the bottom here, which is the pairing. Okay, so whenever we are talking about pairings, is those kind of questions after like the first part is always ask you to expand. So you expand. Then part B, they will always multiply the binomial with another term. Okay, then you must know how to do the pairing. So what I mean by pairing is this. Let's say, for example, if the question asks you, what is the coefficient of x cubed? Okay, so you need to ask yourself, okay, what times what give x cubed? So you have an x squared term here. You ask yourself, x squared times what give you x cubed? Okay, so if you follow my red arrows, it'll be this term here. X squared multiplied by the bx, okay, it will give you the x cubed term. Same thing for the x, same with the x squared, and same thing for the number, you'll multiply by this. Now, please remember that for pairings, right, they are always paired once, so there will never be double pairings. So it's not possible for the x squared to be paired with the x and something else. It's not possible. Okay, so you only pair one time, and it's also not it's not a must to always do pairing. So if you look at the bottom example here, it's not a must. The number 1 actually didn't go through any pairings at all. Okay, so just take note of that. Okay. Sorry, there's some boxes, is it? I don't know whether can you guys still see it. Yeah. Okay, so don't understand. Oh, okay. So what I mean by pairing, right, is that whenever you're doing multiplication across brackets, okay, so you're taking one term multiplied by another term. So the question will ask you, find the coefficient of x cubed for me. Okay, so let's say, for example, I'm given this question here, this one here. Okay, so I have terms that look like this. Okay, so whenever you do the question is asking you to look for coefficients of x cubed. Okay, so what you do, you just look at your x squared term and ask yourself, x cubed times x squared times what give x cubed? Okay, so you can see that you will multiply with the x term, so you'll be bx cubed. That will give you the x cubed term. For the x term, okay, the x term will multiply with what to give you x cubed? Okay, so it'll be the x squared term. So x times x squared will give you x cubed. Same thing for the 1. Okay, if the 1 multiplied by what will give you x cubed? Okay, it's the same thing. 1 times dx cubed will give you the x cubed term. So these are the things that require you to get the x cubed term. Okay, so I hope that is clear. If it's still not clear, later then you ask me. Okay. Yeah. I'm going through the n factorial thing in 1 sec. Give me a sec. Yeah, okay. So let me just go through the 2 examples that I wanted to go through. So the pairing one, just one example of the pairings. Okay, so I'll give you a real life example of a question that does pairings. Okay, so yeah, let me just erase all the notes here. Okay, so the question is this. So first thing, right, let's just look at this one. So the question is asking you how to get the x cubed coefficient. Okay, so x cubed coefficient. So what you're supposed to do is ask yourself, this half multiplied by what will give you x cubed? It's obviously this. Okay, because a constant multiplied by an x cubed term will still give you back the x cubed term. Okay, same thing for the x. 2.5x multiplied by the 80x squared will give you x cubed. 3x squared multiplied by the x term will give you the x cubed term. Okay, so this is what I mean by pairing. So the rainbow will be like that, and like that. Okay. For ascending and descending order, right? If you do your binomial expansion, like how the formula does it, right? It will automatically be written in ascending or descending form. You don't need to do any. You don't need to put any effort to go and change. It's automatic. Okay. Yeah. Yeah. Someone asked about the power n one, right? Yes. It's this question. Okay. So we want to show this particular question here. So this is a pretty okay. It's a simple one. This is quite hard. Oh no. Don't have. Okay, that's the only one. Okay, never mind. So this question here is what? Okay, so they give you an expansion, okay, of k over x cubed plus cx to the power of n equals to that whole disgusting thing there. Okay, and then you need to solve. Okay, so what you're supposed to do, okay, is to go and expand it out first using binomial theorem. Okay, but when you use your binomial theorem, you need to be very careful because your value of here is n. So you do not have a number, so you cannot start from anywhere. So you need to start from the very, very start. Okay, so what we'll do, right, is to go and plug in and just apply. Okay, so if you cannot recall your binomial theorem formula, it's a to the power of n plus, okay, you're assuming that it's a plus b to the power of n. Okay, so a plus b to the power of n. So this will be, first one will be n choose 1. Okay, a to the power of n minus 1, b to the power of 1. Plus n choose 2, a to the power of n minus 2, b to the power of 2. Okay, this is the binomial formula. It's given to you in the cover page of is in your formula sheet. Okay, so you don't need to memorize it. Okay, so this is how I write it. So this is the a term, the n term, the a term, and the b term. Same thing, repeat the process. Okay, now what is so difficult about this is because you don't have any powers. Okay, so when your power is an unknown, you need to know what does this n1 and n2 refer to. Okay, so that's why I came out with a list at the bottom here, which is to memorize what they are. Okay, so most of the times for O levels, they will only test until n3. Okay, so you need to know that these are the formulas. N choose 1 is just n. N choose 2 is n minus 1 over 2. N choose 3 is n minus 1, n minus 2 over 6. Sorry. Okay, so you need to know what they are. Okay, so for those that, let's say, if you want to know how to manipulate from here to get this, actually it's very easy. Okay, you can look for me later. I explain to you, but now don't need, just memorize. Okay, why is this 6? Because 3 factorial. Okay, so this is why it's 6. Okay, so after that, once we expand, so this is just pure manipulation. So you manipulate, okay, and then after that, you will get the answer. Yes, it starts from n0, but n0 is just 1. That's why we don't choose it. Okay, yes, thank you, Casper. 3 factorial is 3 times 2 times 1. Okay, that's why it is that. Okay, I just show lah. Why does this become this? Okay, so the reason is because okay, this is going to confuse people. So if you're not interested, ignore. N factorial is the same thing as n times n minus 1 times n minus 2 times n minus 3 all the way to 1. Divided by r factorial. N minus r, right? Okay, so the formula here is n minus r minus 1, n minus r minus 2, go all the way down to 1. Okay, so what you will do, right, is you will cancel. So you will start your cancellation process because there are repeated terms inside. And that's why when your r value is equals to 1, you see, if your r value is equals to 1, right, let's just write it out for everyone. So this will be n minus 1, n minus 2, n minus 3, all the way down, because it's factorial term. So let's look at the numerators and denominators. N minus 1 and n minus 1 will cancel. N minus 2 and n minus 2 will cancel, all will cancel. So what you're left with is your n and your r factorial. Okay, this is for the case of 1. Okay, r factorial, 1 factorial is 1, so therefore it's just n. Okay, if it's 2, okay, then you will just see, right? If it's 2, right, then you will not have this term here. You will have everything else. So let me write it out for you. So this will be n, n minus 1, n minus 2, n minus 3, r factorial, n minus 2. When r is 2, n minus 3, n minus 4, okay, and then you cancel. You cancel, What you're left with, n minus 1 r factorial. So that's why you get this. It's the same logic. Okay, so just need to know that this comes from this lah. Okay, so I hope this is clear. Okay, someone is asking for independent term of x. So I hope I've explained this enough. Okay, so this is the main way. Now this question is difficult because it's a pure brute force manipulation question. So if your manipulation is not good, then you will struggle lah. Okay, but in general, if you're very careful with your manipulation, go slow, you should not go wrong lah. Okay. Power n questions haven't come up for quite a while already, so it may have a guest appearance tomorrow. If it does, it will kill off half the cohort lah. So because a lot of people cannot do. So yeah, just take note of it. Okay. So just to talk about it, the independent term of x question is here. So if the question says something about an independent term of x, what we do is to always find the general r plus 1 term first. Okay, so we'll find the general r plus 1. So remember where I've already pointed it out where it is. Okay, just take note of where it is. Next thing I will do is to group my terms. So just now I mentioned something about grouping. So I group my terms in this way. This is a number, and then this here is the letter. Okay, this is the x term. And I know that since it's independent, your power is 0. Okay, equate the powers, you get an r value. Now take note, this is something I need to stress. This r here must be a positive integer. It is a must for it to be a positive integer. It cannot be a decimal. It cannot be a fraction. It cannot be anything. It must be an integer. Okay, it must be an. Did I say decimal just now? It must be an integer. Okay, so just be careful. Okay. Okay, so just take note that if your r value you calculate, right, and you don't get an integer, right, means you confirm cock out somewhere. Okay, go and check you're working again. Okay. Okay. For MJ, you say you wanted to go and expand and deduce, right? If let's say your r value here is 16, then you expand for 30 minutes also cannot finish. Okay, so just be careful. Just jump into r plus 1. It's so fast. Okay. How do you find when got 2x plus 9 cubed, like 2 equations for independent? Okay. If you're talking about something like this. Okay, if you're talking about this, then you just expand this, and find the constant. The constant will only be 9 cubed and 9 cubed multiplied together. Okay. So you use the TR plus 1 term whenever you're looking for a specific number within the question. So if you're diving straight down into like one of the term, then you use that. Okay. Okay, I need to move on because I'm spending a lot of time on this chapter. Okay, so for those with still with questions on this, you stay later. Okay, so let's continue first. Okay, for exponential and logarithms, right? Now I know there's a question that came out on it, but what I wanted to do is first is to explain this exponential and logarithm functions. Okay, the graph. Okay, because graphings came out before, and you need to know how to sketch. Okay, so just take note that for logarithm curves, it's always like this. This is longer. And for exponential, it's like this. Oh, like this. Okay, just take note for for logarithm curves and for exponential curves, make sure that this is asymptotical. It cannot cut. Okay, it cannot cut the axis. If it cuts the axis, you are going to get it wrong. Okay, because you cannot log a zero and you cannot log a negative number. Okay, so just take note of that. Now, for this kind of questions also, you will be asked to go and label what is the intercept. So you need to know what these intercepts are. Okay, so if let's say in the exams you completely forgot what kind of intercepts these are, you just need to substitute the relevant values. Okay, so for here, you just need to sub in the x is 0. And for this, you sub in the y is 0. Okay, if let's say you forget, okay, and then you just base off the question. Okay, so these are the logarithm curves. Okay, so yeah, just take note of that. Okay, so next thing, which will be the applications of exponential functions. Okay, so for application questions, right? What I'm actually talking about. Okay, what I'm talking about is all those kind of questions which deals with like half-life of a cell, or like for example, I cannot think of anything on the top of my head. But like those kind of questions where they give you like 30e to the power of negative kt plus something. These kind of questions. Okay, these kind of questions didn't come out. It's applications of logarithm or exponential functions. So you must know how to do such questions. Okay. Just take note that for these kind of questions, part A most of the time will be t equals to 0. Part B most of the time will be like t equals to a number. And then like one of the parts will ask you like, oh, given that the particle is going to be half of the length, find this kind of question. Okay, so I'll just take note of that. Okay. So there are many examples in the paper. Okay, so you can just take note of that. Yeah. Okay. This also can link into kinematics. Okay, so just take note of that. Okay, so yeah. Very good. Okay, so just take note that this is a concept. Okay, it can come out as an application question, and graphing will also come from there. Okay. Logarithms is a good that the 2 questions came out already, and they are super easy questions. So lucky that this year got no difficult logarithm questions. Okay, but yeah, good for everyone. Next, trigonometry and trigo. Okay, so we're going to trigo. Next, for trigo, right? There are a few things that I want to talk about. I know trigo came out for 2 questions already. Okay, so I just want to talk about the 3 questions up there. Then I'll talk about the identities and equations. Okay, so first thing, let's talk about the trigo ratio one. So what is this kind of questions? Okay, if you've never seen this before, okay, this is the one that I'm talking about. So let's say, for example, if tangent A is 5/12, and I tell you that cosine of A is equals to 3/5. Okay, let's do this as B. Okay, so then the question will say that A and B are in the same quadrant. Then ask you to find what is like the sine of A plus B, sine of 360 minus B, all these kind of questions. Okay, this is what I'm talking about. It always comes out. Okay, and a lot of people cannot do. Okay, yes, it's in quadrant 1. Very good. Okay, so yes, just take note that for this kind of questions, there are a few tricks to take note of. Okay, so let me give you the tricks. Okay, so this is tricks to identifying quadrant. So tricks. Okay, trick number 1. Okay, always look out for the positive trigo ratio. So look out for positive trigo ratio. Okay, so what I mean is this. Let's say, for example, if you're given 2, tangent is positive, cosine is negative, for example. Okay, so then I know. So since the tangent is positive and the cosine is negative, this means that we are in the tangent quadrant. Okay, now let's say, for example, if the tangent is positive, cosine is also positive, just like this. Both positive means you must be in the first quadrant. Okay, so this is how to tell. We always look out for the positive one, and they will always tell you something about positive. One will be positive one. They will definitely tell you one. Now the second trick, okay, is to always what is it? Lost my train of thought. Sure. Yeah, sorry, I forgot my trick. Alamak. You look out for the positive ratio and what? Oh, I forgot my second trick. Oh my god. Okay, wait. I'll come back to it. Oh yes, I remember. Okay. Just remember that quadrant 1, acute. Quadrant 2 is obtuse. Quadrant 3 and quadrant 4 is reflex. Okay, so just remember this. Okay, so if the question says that A and B is acute, automatically quadrant 1. Okay, if it's obtuse, it means that it's in quadrant 2. 3 and 4 is reflex, but always check, always double check with whatever ratios they give. Okay, now just to stress one example, if let's say the question gives you tangent A equals to A, it's not just A, okay, must be careful. Tangent A over A is basically A over 1. So this means your opposite over your adjacent. Your opposite is A, your adjacent is 1. Okay, so just take note of that. Okay, very good. Yeah, okay, so all these kind of questions, okay, just take note. Okay, so I hope this will help you tomorrow. And this kind of questions here, okay, always look out for Pythagorean triplets. Always look out for yes, it's positive. Look out for Pythagorean triplets. Always look out for Pythagoras theorem. Let's say, for example, if they give you like disgusting fractions like 3 over 13 or like very gross numbers, okay, then use Pythagoras theorem to solve. If you can spot like Pythagorean triplets like 3, 4, 5, 5, 12, 13, 9, 21, 20, that kind of thing, then it's obvious. Then don't need Pythagoras theorem anymore. Okay, but most of the time just plug in Pythagoras theorem. The most difficult type will be those, instead of numbers, they give you letters. Those then is a bit more messed up. So then yeah, you need to do the Pythagoras theorem and manipulate it on your own. Okay, I do have a demo of a question that I prepared before. Where was it? I know it scared some people. Yeah. So if you see something like this, so for example, if the question gives you like, A is an obtuse angle where sine is P, and B is an acute angle where cosine is Q. Okay, and then you need to find. So just remember, okay, whenever you have one of the trigonal ratios, you can solve for the other two. My suggestion is to always draw the table. Write out what is sine, write out what is cosine, write out what is tangent. Okay, and then make sure the signs are correct. Okay, then of course your manipulations, make sure you be very careful. Okay, if it's like tangent 2a, make sure you plug in the double angle formula. You plug in the addition formula. Please do not, please, I say for anything that is holy, like legit hot. If let's say your tangent A is 5 out of 12, and the question asks you to find tangent 2a, please do not do this. Wow, 2 times 5 over 12. Please don't do this. It's wrong. Tangent 2a, you must open it up using double angle formula and then apply. Okay, so just remember, do not just go and do that. And also, please, for those sine A plus B, please don't. It's not the same as this. Okay, please don't do this. It is confirmed wrong. Okay, so please be careful. Okay, so yes, by the way, this kind of mistakes cannot make. Okay. The chat box blocking half the screen. Okay. Oh, okay. Sorry. Thank you for letting me know. Sorry, my computer small. Sorry. Wait. Okay. Can see. Okay. Yeah. Okay. Sorry. Okay. So just take note of this. Now, for those right that have like the okay, I know someone confirm us this one. 180 minus b. Okay. Don't need to scare. Okay, so this kind just open using addition formula. Sine of 180 cosine of b minus cosine 180 sine b. Ta-da! Okay, so you just open it up like this. Okay, so these are for those with the funny angles inside. Okay, just take note of that. Okay, yeah, I think I should copy this over. Yeah, put it. Oh man, no space. Sorry. Yes, there's one more I want to talk about because I know confirm will come out one. Where is it? Where is it? Someone asked about half angle formula, right? I need to find. I got right before, but I forgot where I put it. No. Half angle formula. Wait, I confirmed got right before. There you go. Half angle formula. It's not always like it's not a very popular question, okay, for half angle formulas, because you can derive straight from the double angle formula or half angle double angle formula, but most of the time it's not tested lah. Okay, so just take note of that. Okay, so I think I'll screenshot this and put it over. It's important. Okay, so if you're interested, you can take a look at it there. Okay. Okay, next, let's move on. Next one, exact form of trigonal ratios. Okay, so for exact form of trigonal ratios, right? This is the one where they tell you about the they give you the specific ratios. So like for example, I'll give you a demonstration. Like for example, the question says sine of 105. They ask you to find what is the exact form. Okay, so exact form. Okay, just remember that for exact form questions, always break down your angles, okay, into the field, the golden field, 30, 45, 60, and 90. Sorry, yeah. Okay, always break down your angles into the golden field. Okay, then after that, you can start to expand. So for example, this sine 105, okay, this will actually be the sine of 60 plus 45, and expand. Okay, so this one just apply the double angle formula, addition formula to get the answer out. Right. So this will be sine 60 cosine 45 cosine sine 45 cosine 60. Okay, then all of this is just pure memory work. Okay, so for this kind of questions, always cannot use calculator. Make sure you expand now. So this is 3/2. Cosine 45 is 1/2. Sine 45 is 1/2, and cosine 60 is half. Okay, so when you get this, then you just combine them together. Okay. Yeah. So this is for exact form. For principal value and for I saw questions on principal value, right? Principal values. You just take note that you can just plug the answer into the calculator. You'll get the answer. Okay. So just take note of that. Find maximum minimum value. That one is in Trigograph. Trigograph already came out, so I don't think it's necessary. But if you are curious, just let me know later. Okay. Okay. So yeah, I think that's about it. Okay. So principal range. Okay, fine. Let me just write it down. Principal angles is this list. So where are you? Where are you? Where are you? Where are you? There you go. Principal values. Okay. So these are the principal values. Okay. For sine, cosine, tangent. Okay. So let's put it here in case anyone needs it. Okay. Just take note of the inequality sign. Some more stress. Oops. Too big. This, and this. For the last one, it's less than or greater than. The first one is less than equals to, greater than equals to. There is a difference. So be careful. Okay. Yes, for cosecant 105, you've worked out the 105 and flip. Yes, very good. Okay. Okay. Now, last thing, R formula. Okay, R formula always comes out every year, but N level never come out. Okay, so for R formula, just take note that R formula, you can brute force the answers out for R formula. So in case you forget what is R and what is the alpha value, you can brute force it using quadratic. You can use it the you can brute force it out using the addition formula and the identities. Okay, so let me just show you my handwritten notes because I think it's here. Yes, it is. Okay, so for our formula, okay, just take note that the R is the Pythagoras theorem. Okay, so it's a squared plus b squared. Okay, and the alpha value is tangent inverse of b over a. Okay, so if the question asks you like, how to tell whether the question asks you for our formula? Actually, very obvious one. When one of the parts will definitely tell you express your that sine cosine theta plus sine theta equals to r something something something. That one is obvious in our formula question already. Okay. Yes, I know people asking about maximum and minimum of our formula, right? Okay, so this one I can go through because I know it's difficult. Okay, so for the maximum and for the minimum of an R formula, right? Okay, what we always do is to always imagine the graph. Okay, so for maximum and for minimum, right? Okay, now for the maximum point, for let's say a sine curve. Okay, so let me just write it here so it will help people. Okay, so this is going for alpha b. Okay, so for our formula, right, when they ask you to go for the maximum and minimum, so let's say, for example, if my question is this, the square root of 26 cosine of theta plus 30, for example, and the question asks you for max and min. Okay, what you do actually really simple. Okay, so what you do, right, is you go and imagine a cosine curve. Okay, so I'm going to sketch out the cosine curve. Okay, so the cosine curve will look like this, and then you ask yourself, what is going to be this value here and this value here? Okay, because then you want the max and the min. The max is here, and the min is here. Okay, so if you're sharp enough, you realize, okay, that the max and min, right, is actually your amplitude. Ta-da! Okay, so the maximum value is going to be the root of 26, and the minimum value is going to be the root of negative 26. Okay. Now, for the corresponding value of theta, okay, this is a trick that I think a lot of schools don't teach you, but it's actually very obvious once you realize how to do it. Now, to find maximum, right? Okay, there is no fixed way of doing it, but just draw out the curve and trust me on this. Okay, when you're dealing with the maximum point, look at your graph. Ask yourself, where is the very, very first point where your this graph is going to hit your maximum? Okay, it's going to be here. It's when it's 0. So this means what? Is when the cosine of theta plus 30 degrees is 0. Okay, so this is when it's going to be. And then you ask yourself, same thing for the the angle. Sorry, not the cosine, the angle. Okay, and then for the minimum, just ask yourself, when is the very first time this thing is going to touch the minimum point of the graph? Okay, here. Okay, and if you're sharp enough, you know that that is actually 180. Yeah, it's 180. So it's theta plus 30 degrees. Okay, it's the same thing. Okay, as your just look at where is it going to be on the graph. Okay. Okay, this is for our formula. Okay. Okay. So this is our formula. Okay. So if anyone still has any questions for our formula, then you let me know. Okay. So let me just check out for the our formula questions. Is there anything I can demonstrate at the back? Don't think there is. What? Yeah. Okay, so yes, for the one and for the negative one, right? If your method is slightly different, then you just learn whatever way that you learned it. Okay. Most of the people will just do the one and negative one thing. Yeah. So for cosine, it will be, if I remember correctly, it's 1, and then for the minimum will be -1. Yeah, because it will be where the graph will actually be at. Okay. Yeah, I think so. Hey, wait, did I do it wrong? No, I didn't. It's correct. Okay. Yeah. Okay, so yeah, this is how to do it. Okay, anyone else got questions about this? Later then you look for me. Okay. For drawing graphs, no, I won't go through now because it came out already. Okay. Yeah, let me just double confirm something. Yep, correct. Wait. Yeah, that's correct. Okay. How I get the 180 is because this is the point where it's going to be the minimum point. Okay. So the minimum point is going to be where it's at 180. Therefore, I'll equate the angle is equals to 180. Okay. Then you just solve. Okay. Yes, I saw the comments about the trigo graph. The trigo graph, the application questions for the finding the values of A, B, and C already came out. Okay, but the chances of the graph sketching coming out will be very low. Okay, but if people want, then I go through. Okay, wait now, let me clarify this later. I think I may have made a mistake here. Trigo graph. Okay, in case anyone wants, sine, cosine, tangent. Okay, so this is sine, cosine, tangent. Okay, so if the question comes out on negative graph, then it's just the reverse. Okay, so the blue curves are your negative, okay, and your red curves are your positive. No, there will not be an inverse graph. Inverse graph is not in the syllabus. Okay, so yeah, just take note of this. Okay, for those with questions of the R formula later after this, then you look for me, just in case. But let me just double check later after this. Okay, blue is negative and red is positive. I'm quite sure I'm correct, but I don't know why it looks weird just now. Okay. For tangent graph, how do you know which is the asymptotes? Memorize. This is 90 degrees. Negative 90. No, pure memory work. Okay, it's 90 and 270 for tangent graphs. Just memorize. Okay. Yep, that's all for trigo. Okay. For identities and for proving, right? Yeah, I know that even though it came out once already, but there is still a chance that it can come out again, and you never know. So please go and still practice your proving questions. It may come out again. Okay. Very good. And that's all. Okay. So let's move on to the circles and linear law. Okay. I know that a lot of people are wondering for these two chapters. Okay. For those with questions on trigo, later you stay back, then you look for me. Okay. And I'll clarify the R formula one, just in case I've made a mistake. If I have, then I will put a little post somewhere to tell people that I've made a mistake about the R formula. Okay, but I don't think I'm wrong. I just want to double confirm, okay, in case I teach people wrongly. Now, for circles, right, there are a few things that we can take note about. Okay, for the further coordinate job. So I'll use this set of notes, then I'll just upload there later. Okay, these notes are already in the chat, just in case you're wondering. Okay, so we start with the standard formula for a circle. Okay, so first thing is that you have an equation, the standard form, and for the general form. Okay, so for the standard form is x minus a whole thing squared plus y minus b whole thing squared equals to r squared. Okay, you need to take note as to where this r squared value is. Okay, sometimes the questions, the r will be on the left. So you need to be very careful. Okay, so you must make sure that it follows this general form when you plug in your, when you find your center and when you find your radius. Okay. Now for the second one, which is the general form, okay, x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Okay, this one you need to check and make sure that the equation is of this form. Now, I've underlined the c there is because sometimes questions will throw the c on the right. Okay, so if the c is on the right, then you must be very careful. You must throw the c back to the left and make sure that the c is positive. So let's say I give you a hypothetical example. If the question come out there to be negative 26, okay, the c is negative 26, for example. Okay, so what you can do is just negative of plus 26. Okay, so yeah, okay, so then you can get it. Sorry, negative 26. Okay, sorry, what am I doing? Plus of negative 26. Yeah. Okay, then after that, the c value will be negative 26. Okay, so just make sure that the C value here is positive. Okay, yes, it's true. You can complete the square to jump back from the second form to the first form, but in my personal opinion, that's a complete waste of time. So doing just straight from the general form is a lot faster than doing completing the square 2 times to get out the R value and to get out the x minus a squared. In my personal opinion, it is very slow. Okay, but I think that using the general form is a lot faster. Okay, so that's why I preach the general form better. Okay, take note that the center is negative, so it's negative g negative f. Okay, don't forget that. Okay, and the radius is g squared plus f squared minus c. Now the constant here is minus, okay, but the c value must be positive. So if let's say for example it's just now minus 26, right, and your c value is negative 26, so when you minus c, it will be minus negative 26. Okay, now if the question just asks you to show or find equation or circle, you can leave it in either form. It really doesn't matter. Okay, but if you are very scared, then leave it in the standard form. Okay, but in general, because both are universally recognized, you can just leave it as it is. Okay, now just 2 more concepts that I want to go through. Okay, these 2 here, reflections and normals. Okay, so these are the 2 main chunks that would cause people to make quite a bit of mistakes. So let me drink water first. Okay, so first let me talk about reflection. Okay, so what does it mean by a reflection? Now, a reflection means that you're having a mirror image. So if you came from my crash course, okay, you have heard this this little not joke but it's an analogy that I use to explain reflections. Okay, so just use it now as well. Okay, so what does it mean by a reflection? Reflection, you can take it as like I'm looking at a mirror image of myself. Okay, so I'm going to use the reflecting about the y-axis as an example. Okay, so how do I remember, like what are the conditions for reflection? Okay, so there are 3 things to remember. Okay, so for example, right now I'm me. Okay, if you can look at my screen, right, I'm me. Okay, my monitor in front of me right now is my mirror. Okay, and I'm looking at my mirror image. Okay, so when I look at my okay, I hope this is better. Okay, so when I look at my mirror image, right? Okay, so my first question that I ask myself is this: when I look at my image, is my image going to be at the same location? My camera is off. It's on now. Don't scare me. My camera is on. Okay, so my image, right? Is it going to be at the same location as where I am? Okay, of course, in the image world, is it going to be in the same place? Is it going to be further away, or is it going to be closer than me? Okay, it really depends. Okay, you must make sure that okay, it's supposed to be at the same distance. Okay, like for example, if I'm 5 meters away from the mirror, it'll be 5 meters from the image. Okay, so just take note of that. Okay, so make sure that the images are the same distance. If let's say you are standing further away and like you are standing 5 meters to your mirror, but you see your image like 10 meters, okay, something is wrong. You should throw the mirror away. Your mirror haunted, very scary. Okay, so this kind, remember that if you're 2 meters away from the image, if you're 2 meters away from the mirror, you should be 2 meters away from the image. Okay, so that's what I mean by the x coordinates do not change and the y coordinates do not change. Okay, so if you're reflecting about the y-axis, right, this is what I'm talking about, reflecting about the y-axis. Okay, so what is the thing that changed? Okay, the position between me and to the mirror and from the mirror to the image didn't change at all. Okay, so what this analogy here trying to say is this. If I have a circle, for line, circle. Okay, the distance between here to here and the distance from here to here is identical. Okay, so just take note of that. Okay, next example that I want to go through, okay, which will be talking about the x and y coordinate one. So let me explain that. Okay, so if let's say I'm looking at my image down here, okay, so when I look at the mirror, okay, will I be floating above or will I be floating into the ground? But the answer is no. Same thing. If you see this kind of thing, you should throw your mirror. It's very scary. Okay, it's haunted. Okay, you're supposed to be standing at the exact same location. Okay, so this means what? Okay, that your y coordinate actually shouldn't be moving. You're supposed to be staying on the exact same plane. Okay, you shouldn't be moving at all. Okay, and the only thing that is changing is your x location. The only thing that moved is you are moving from the real world into the image world. Okay, so that's why the y coordinate doesn't change. You do not move up, you do not move down. Okay, you're supposed to just stay there. Okay. Now the last one is talking about the radius. Okay, so this one is logic lah. Okay, if you're looking at a mirror, okay, imagine that this mirror is a completely normal mirror. Okay, not convex, not concave, not any special mirror. Okay, do you get fatter? Do you get skinnier? No. I wish I can get skinnier lah by looking at a mirror, but it doesn't work lah. Okay, so remember, okay, that for radiuses, right, your body, okay, your body size will still stay the same. So this means that your radius, your image should still stay the same. Okay, so that's why when you're reflecting about something, your circle size should stay exactly the same. The only thing that changes between reflections is your center, is your location. Okay, so I hope this is obvious lah. Okay, so this is what I want to talk about. Now, I know there are people talking about like reflecting about a line, reflecting about like y equals to x. Okay, for those kind, it really depends on the question. Okay, the most common one is reflect about y and reflect about x. Okay, for those they are reflecting about some random line, right? Yes, the radiuses will never change. The only thing that changes is your new c coordinate, your center. So you need to use the equation of the line that is given to you to go and find where is your new center. Okay, so the methods you use perpendicular bisector to solve. Okay, so just take note of that. Okay, just two more concepts that I want to talk about, which is normals and tangent. Okay, so for normals, right? Okay, just take note of this. Okay, now there are questions where they tell you like, oh, I have a normal here, I have a normal here, and then randomly they ask you to find what is the center of the circle. Now you need to remember this concept that normals will cut the center. Okay, so let's say for example, if I have two normal lines, right? Two lines that are normals to each other or to the circle, okay, these two normals will intersect at the center. So you just need to do simultaneous to get out the center equation. Take note, it's the normal, not the tangent. Okay, so you can see the diagram down there. Okay, the blue lines are my normals. These normals will cut the center of the circle. Okay. Yes, reflect about x-axis means circle on top and below. Yes, correct. Okay, and the last one is talking about this concept here about tangents of a point on a circle. Okay, so for this concept, now sometimes the question will tell you, I given a circle equation and they ask you like, oh, given the point P is equals to 2, 3, find what is the tangent of the circle at that particular point. Equation of the tangent of the circle at that point, for example. Okay, so what is the way to do it right now? Because in O levels they don't teach you implicit differentiation, so you cannot differentiate the circle equation. You do not know how to differentiate a curve, a circle with x and y inside. So no choice, you need to do the longer method. Okay, so what you need to do, okay, the first step is to actually go and find what is the gradient of the normal. Okay, and this actually helps me to answer the question that just came out. Why is it that the normals will always intersect at the center? Okay, it's because your tangents are always perpendicular to the radius. Okay, so if you think back to your EMF, your properties of circle, your tangents are perpendicular to your radius. Okay, so wherever you have a normal, right, your this normal is essentially like a radius. So your these radiuses will confirm plus chop cut the center. Okay, if it doesn't cut the center, means it's not a radius. So that's why it is a must for it to cut. Okay, that's why I got so many people say the same thing. Okay, that's true. So the first thing to do whenever you're looking for a tangent of a point on a circle is to go and find what is the gradient of the normal. So you're given the point, you're definitely given the center, so you can find the gradient. After that, you apply the perpendicular line. Okay, so perpendicular means that it's product -1. Okay, and then after that, you already have the gradient there, which is your -1 gradient. And then after that, your point. You just substitute in, you get your answer. Okay, so unless you know how to do implicit differentiation, which I don't think anyone knows, okay, but or else this is the only way to solve the question for tangents of a point on a circle. Okay, yeah. So these are the main concepts for circles. So just leave it as it is. Okay, so if you have any more dying questions for circles, later then you ask me. one last concept that I want to talk about. I think someone asked just now, how do you tell whether a circle is within a circle? That one actually very easy. What you do, right, is you go and identify where the centers are of the circle, okay, and then you go and draw. And then you go and figure out radius. Okay, so how will I tell whether, okay, this is my method lah. At the top of my head, how will I solve a question about whether a circle is in a circle or not? So if I have a circle and I have a randomized circle somewhere else, what I will do is to try and find where is the center of the big circle, where is the center of the small circle, and calculate what is the distance. If the distance between the two centers is smaller than the biggest circle radius, is confirmed inside. If it's equals to the radius, means that it's cutting like that. If it's more than the radius of the circle, then it's confirmed outside. Okay, so that is to answer that question. Someone also asked before, how do you tell whether like a line, like for example, how do you tell whether, okay, let's say for example, if I have a circle, okay, and I tell you there's some randomized point here. Okay, yeah, I know two circles not in the syllabus, but someone just asked, so I don't really care. So I just answered. Okay, so if I have a circle and someone just asked like, given I have a point that, can you determine whether this point is it inside the circle, on the circle, or outside the circle? So the way to do it is to calculate distance. Okay, you calculate the distance from the center of the circle to the point. Okay, so when you calculate from the center of the circle to the point, if it's smaller than the radius, it's inside. Equals to the radius is on the circle. Outside is outside the circle. Okay. Yeah. Yeah. For those people asking, is because questions dealing with two circles on top of each other is not. Okay, cannot really say not in the syllabus, but it will not be tested. Okay, because it's explicitly stated in the syllabus guide that it will not be tested. School prelims got come out lah, but I don't know about O levels lah. This is the first year 4059 is being tested, so yeah, we shall see. Okay, but yes, that's just to answer that question. Okay, it was an interesting question, that's why I entertained it. Okay, so yeah, this is for further coordinate job. Okay, next, linear log. Oh my god, I'm taking so long. Oh my god. Okay, I'll finish within the next 15 minutes. I'm so sorry. Okay, so for linear log. Okay, and then after that, I'm done with calculus, integration, and kinematics. Okay, so for linear law, this is a completely fresh chapter as well. Okay, so I just want to use my notes to explain. Yeah, it's just like that. Okay, so for linear law, right, there are two types of questions that can come out. It's those kind of questions where you do not need to sketch the graph, and those that you need to sketch the graph. Okay, arguably the sketching graph one is easier than the don't sketch graph one, in my personal opinion, because sketching graph is very mechanical. It's always the same. What you do is that you'll give you the equation, you change the equation into capital Y equals to M capital X plus C, and then after that, you sketch the graph. Okay, then you extrapolate to the x-axis, find gradient, find y-intercept, solve, finish question. Okay, that is for those kind of questions. But for those kind of questions where it's purely just they give you a random graph and they tell you some random axis, then you form the equation. Those kinds are a bit more difficult. For those kind, you must remember that you're always going back into the main form of y equals to M capital X plus C. Now, a few tips for this chapter. You must always show your manipulation. So for example, if you're converting between y equals to AB to the power of X to the capital Y, you need to show the working. Okay, it's necessary. Okay, and also just be very careful of your x's. Sometimes your x's is like 1 over y, 1 over x. Sometimes it's log y, log x. You need to be very careful what they are. Okay, and the last tip at the bottom here is to extrapolate. Okay, so most of the time your graphs, right, will always be floating in the middle out of nowhere. Okay, so what I always tell people to do is to go and extend the line all the way to the y-axis. The reason is because the chances of you calculating for the unknowns of your y-intercept and your x-intercept is very high. So just go and extrapolate. There is no problems with it. In EMATH, you cannot extend past the questions range, but for AMATH, you can. Okay, so you can just extend all the way. Okay. So how do you know which one to put as the x-axis and which one to put as the y-axis? Most of the time it will be very obvious based on the question. Okay, so most of the time it will be very, very obvious. Can it be a best fit line? It depends on the points given to you, but most of the time, no, it will be exact. Okay. Does the x and y have to start from 0? Yes, most of the time. It really depends on the question. It depends on the value. Okay, so yeah, it really depends on what kind of values you're getting. Okay. Okay, most of the time they will also tell you to plot what against what. Last time my generation, they don't tell you. But now most of the time they spoon feed you the graph. Sometimes they don't, but most of the time they do. So don't need to worry. Okay. Yeah. Is it okay to show the changing of equations? Okay. Yeah, this is just a demonstration. I don't want to show all because there's a lot of types. I don't want to show all because there's a lot of types. Okay, but y equals to ax, b to the power of x. Usually how to tell, right, is, wow, this one also very hard to see. Okay, give you an example. Let's say, for example, if I'm dealing with this one, y equals to ab to the power of x. How do you tell what is the y-axis, what is the x-axis? Okay, now, most of the times they will tell you the question that a and b are constants. Okay, so if your a and b's are constants, okay, then you know that those will be your gradients and those will be your y-intercept. Your x and y most of the times will be your terms that you use. Okay, now if you have an x that is above here, you will use logarithms to go and split them up. Okay, and you'll write an equation into the form of log y equals to x log b plus a. Okay, so when you have an equation that looks like this, right, how do you tell? This is definitely going to be your y. This is your capital Y. And remember what I say, the things with the b's and the a's will be your y-intercept and your gradient. So you can see that there's a constant here multiplied by a term, and you have a constant. So this, by deduction, this should be your gradient, this should be your capital X, and this should be your C. This is how it done. Of course, it comes with a lot of practice and a lot of experience. Okay, but most of the time it's very straightforward. Okay, and they will usually tell you so don't need to worry too much about it. Okay. Yeah, this is linear law. Most of the time, linear law is like a e-learning kind of chapter because it's very easy. So yeah, I've never seen a super difficult linear law question before. Maybe it's tomorrow. Maybe we shall see. Okay. Okay. Yeah. Just want to complete this. Okay. So this will be differentiation. Okay. My favorite chapters: calculus, differentiation, integration, and kinematics. Okay. Now I know I'm not writing anything here. I will post. I'll put stuff later. So yeah. Okay. So for standard differentiation, right? Differentiation. There are a few questions that came out already, but there are a few that didn't. Okay. So these are the few standard differentiation identities: increasing, decreasing functions, gradient, tangent, normals, and maxima, minima. Okay, now gradient, tangent, normals were linked to circles. That's my bet. Okay, so that one will throw up there. Okay, into the circle chapter. Now, maxima, minima is the kind of questions where they give you like, oh, stationary point, given that x can vary, find what is the biggest possible value of a, that kind of questions. Okay, so I will go to the respective chapters now. Now, we talk about standard differentiation first. So please remember that differentiation is always power bring down, power minus 1. Okay, product rule, quotient rule. Now, all these notes is already been uploaded. Okay, so in case you've never seen them before, just scroll a little bit up and then you'll see. Okay. Next, the identities for trigonal, exponential, and logarithms. Okay, you need to know what they are. Okay, just take note that if let's say your angles is ax plus b, you need to differentiate the angle. Okay, so it's a cosine ax plus b. Okay, if it's exponential, it will be a e to the power of ax plus b. Okay, and then if it's logarithms, it will be ln x is 1 over x. Okay, so the list for O-level differentiation is very short, just like that only. Okay, so just need to remember this. Okay, there's nothing too much, there's nothing too difficult about this. Okay, is there anything to say? Honestly, no. There's no way to check unfortunately, there's no way to back check for differentiation. So you have to be confident of your answer, just like the integration question 4. Yeah, you just need to be confident. Okay. Next one will be increasing, decreasing function. So this one never came out before. Okay, so let's say if we sine square ax plus b, you need to throw the 2 down. So you'll be 2 sine, how to differentiate tangent square of ax plus b? Okay, how to differentiate the squares, right? It's the same logic as normal differentiation. So you will throw down the power, okay, then you differentiate the term, then you differentiate the angle as well, and you get the answer. Yeah. Okay, so it's the same thing. Okay. Wait, is sine square even in the syllabus? Yeah, it is. Okay. Okay, so increasing, decreasing function. Okay, so this will be greater than 0 and less than 0. So just remember, okay, that your dy dx greater than 0 means it's an increasing function. Dy dx less than 0 means that it is a decreasing function. Okay, so just take note of that. Next, for stationary points, okay, this one didn't come out. Yes, it did. Okay, so it came out already. Natures also came out already. So ignore. Second derivative came out already. Okay, gradient, tangents, and normals. Okay, so whenever you're dealing with a gradient, tangent, and normal question, remember that the product of the tangent and the normal is -1. Okay, remember that the equation itself, y equals to mx plus c, the m is your gradient, and your dy dx is your gradient of your tangent. Okay, so just remember the difference between the tangent and the normal. The normal is the line that is perpendicular to your tangent. Okay, so these are the questions that will appear most of the times with the circle question. So that's where to take note of. Okay, now for maxima, minima. Now the questions never come out before, but for maxima, minima questions, usually the part 1, the proving of like some funky formula, those are most of the time the more difficult ones. The behind is more straightforward most of the time. Okay, so in the event, let's say you're very stuck with the beginning, just skip and then just solve the differentiation. If the beginning is very hard, okay, but most of the time it's solvable. Okay, so just take note of that. Maxima, minima questions is always dy dx equals to 0. Okay, so you must know how to show, okay, and how to differentiate. Okay, and also remember that you need to actually prove why something is maximum or why something is minimum. Okay, you use your first test and second test, unless the question specifically say don't need. Okay, so sometimes questions will state like, oh, you do not need to show that it is maximum or minimum. Okay, but if the question never say, just show. Okay, so you just plug into second test or plug into the first test to prove that the answer is indeed maximum or minimum. Okay. Okay, so this is it. Rate of change already came out, so I'll just leave it to you. Okay, if the question is similar to the paper 1 rate of change question, I haven't seen it yet, so later I'll talk about it. But the rate of change won't come out again because it already came out. Okay. Yes, if the second test fails, okay, so if the second test is equal to 0, you need to state that it is inconclusive. So therefore, you need to redo the first test for that particular value. Okay, that's for hello. Okay, integration. So based on my notes here, integration here, first one is integration as a reverse of differentiation. Okay, definite integrals and applications to definite integrals. Okay, so let's talk about them. Now, the applications to that one I'll talk about it, the below one. So that one later. But I want to go into definite integrals first. So I know integrals already came out. Okay, but definite integrals may come out again. So it's those with the corners with the limits. So you need to know how to react to them. Okay. And also, right, some things whenever you're integrating, you must remember to write the dx and you must remember to write the c. So for those on Monday forget to write, too bad. Okay, so you must remember to plus c okay, whenever you're integrating something. Okay, if you don't, you'll lose marks for it. Okay. Yeah, for definite integrals, right? You must always remember the few rules. Okay, the first one is the fundamental theorem of calculus, okay, which is this one here, where you substitute the limits, okay, and then you integrate normally. So that's pretty easy. Okay, so yeah. And then whenever you're integrating with respect to the same limit, so let's say a to a is 0, okay, and there's a negative sign on the outside, you just flip. Okay, now the one I want to talk about is this one, okay, which is the first point, which is the concept of integration as reverse of differentiation. Okay, so I want to talk about it. Okay, so okay, so let's say for example, if you're given a question, d over dx is equals to that. Okay, so they differentiate for you already, and then part B, they tell you to integrate that. Okay, so how do you do these kind of questions? Now, these kind of questions will plague O levels the most, because a lot of people don't like these kind of questions, and they usually, okay, not usually, comes out all the time. So you must know how to do. So how do we do these kind of questions, right? Okay, just look at my example here, and I hope that it'll be clear. Now, if you look at this is the integral that we're interested in. Okay, so this is the integral that we're interested in. And what we do, right, is that we're going to use whatever part A tells you. Okay, so part A tells you 3x over the root of 2x minus 1. Okay, so that is what we need. Okay, so we're going to use this right here. Now, how do I tell the 2 over 9? Okay, this 2 over 9 really depends on whatever values they are. Okay, so if you have the orange ones, okay, if you can see, right, let's talk about the numerators first. Okay, now for the numerators, right, there's a 2 and a 3. Now, from the left-hand side to the right-hand side, what has happened? I need to introduce in a 2, and I need to remove a 3. If you see from my wordings below. Okay, so in order to remove the 2, I need to put the 2 in the numerator. If I want to remove the 3, then I will have to put it in the denominator. Okay, so this 2 over 9 actually is made up of 1 over 3, 2 over 3, sorry, multiplied by 1 over 3. Okay, so the first 3 at the bottom, right, will help you cancel the 3. So if you think about it in your head, right, what is going to happen is that this 3 is going to cancel with this 3, and this 2 is multiplying in. Ta-da, we get the 2. Okay, so I'm working backwards to get out the number there. Okay, now how about the denominator? I have a random 3 there, but it vanished into thin air. Okay, so what I need to do is I need to add in the 3 in. So no choice. Okay, I need to add in the 3. So therefore, I'll throw it into the denominator to make both sides of the equation equal. Okay, so the reason you need to add and you need to remove is because you need to make both sides equal. Okay, because right, you need to use part A's answer to get out the answer, or else there's no way you can integrate. You have never learned how to integrate square roots like this. So you no choice need to go and change this particular square root into this. Okay, so yeah, I'll explain this again because I know it's difficult. Okay, so part A will tell you this. Okay, that the d over dx is equals to 3x over the root of 2x minus 1. Okay, next, you need to find what is the integral of 2x over 3 of the root of 2x minus 1 dx. Okay, so how to do? What you need to do, right, is that you need to go and find part A's answer and put it right here at the corner. Okay, so no choice, you need to go and put it there. Okay, you need to use part A's answer to get out the integral. Okay, now your objective is what? Can we remove this? Okay, you need to change this whole thing right here on the left to the thing on the right. Okay, you need to go and convert. Okay, because you need to make it equal somehow. Okay, you're putting an equal sign, so this means that both must be equal. Okay, so now let's start talking about the numerator first. How am I going to make the numerators equal? Okay, now I have a 2 on the left, so I need to introduce in a 2, or else it will never be equal. Okay, so if I need to introduce in a 2, it will go up in the numerator. So what happens? If I put in a 2 there, okay, it's going to be 2 times of the integral, so I have a 2 in the numerator. But the problem now is that there's a 3. Okay, this 3 here is extra. It doesn't appear at this 2 here. So you need to remove it away. Okay, so in order to remove the 3 on the right-hand side, so you divide it away. So what happens here? Okay, so if you're very confused as to what is happening right now, ask yourself what has happened. If I put the 2 over 3 there, what has happened? The 2 over 3, right? I'm going to cancel in blue. The 3 here is going to cancel with this 3 in the denominator, and the 2 is going to multiply in. So what has happened? Oh, I have made the numerator into 2x. So that's what I've done. My objective is to make both sides equal. Okay. So yeah, this is for the denominator. Okay, numerator. Now we talk about the denominator. So let's just ignore this 2 over 3 first. So I'll just leave it at the side. Okay, now I'll ask myself, okay, I have a 3 here and I have nothing here. So no choice. Okay, to make both sides equal, I need to introduce in the 3. So in order to introduce in the 3, I need to throw the 3 into the denominator. Okay, so that's why it's 1 over 3. That's why the full solution is 2 over 9. Okay, so this is the way to actually fish out the number that you need to put in or to take away or whatsoever to make both sides of your integrals equal. Okay, now this question right here is the easy version of the chapter. There are many levels that makes this difficult. Okay, so the few types is like you may need to add in an additional term or what. Okay, so let me just show you first. Because this is the very last concept really. other than integral. Okay, so this is what I was talking about. Okay, so if anyone wants to screenshot, I let you screenshot now. Okay, so this is what I'm talking about as to how to actually get out the answer for the 2/9. Okay, so yeah, I'll show you some example questions. Okay, so let's say for example, if I'm starting from a differentiation, then I go into an integral. This is how to do it. Okay, the main method is to always like introducing, oh, what do I need to introduce, or what do I need to take away in order to make both sides of the equation equal. Okay. Yeah, this always appears in O's, so just take note of it. Okay, go and practice TYS. There are many questions there. Okay, very good. Okay, for those that are still confused, later. Okay, later then I'll help you. Okay, last thing will be kinematics. Okay, this is a completely fresh chapter, so it will guarantee come out one. Okay, so for kinematics, okay, just a few things to take note of. Okay, I'll just use my notes here, it's a lot faster. Okay, so for kinematics, right? So for kinematics, the first thing is that I always teach students to draw this diagram. Okay, so this little curvy diagram here. Now, this is something that I ask them to just write onto every integration question or every kinematics question because it's very powerful. Okay, let me explain what it means. Now, if you're given a displacement equation and you want to find velocity, you differentiate. If you're given a velocity equation, want to find acceleration, you differentiate. If you're given an acceleration equation, want to find velocity, integrate. If you want to find the velocity equation, if you're given a velocity equation, want to find displacement, integrate. Okay, this is how this diagram helps you. Okay, so with this diagram here, it's very obvious what you need to do and what the question wants. Okay, now usually in the kinematics questions are most of the time pretty easy. Okay, so just take note of that. Okay. Yeah, just need to remember also that for instantaneous rest, it means that the velocity is equal to 0. Okay, and instantaneous rest, most of the time, we're talking about a change in the direction. Okay, so there will be a loop backwards, back to a different direction and whatsoever. Okay, next, for the third second, okay, so that will be between second and third. Okay, so just remember that. Okay, so between, if let's say, for example, they're asking you what is the distance traveled between the second and the third second. Okay, so we are actually looking for second and third second. Okay. Now, last concept before we end today, okay, will be this. So the difference between distance and displacement. Okay, so sometimes questions will ask you what is the definition or what is the distance traveled or what is the displacement traveled. Now you need to be clear what they mean. Okay, displacement is the one in green, distance is the one in red. Okay, if let's say I'm looking for the distance traveled between O and P, you need to include the direction that you have turned. Okay, so the backwards direction. Okay, if you're looking for the displacement, for those that take physics, you should know that displacement is just straight from the origin. You draw a straight line to the corner, you get the answer. Okay, so that will be the one. Okay, yeah. Okay, so that's the difference between distance and displacement. Okay, last thing, general convention is that we always keep positive to be on the right, negative will always be on the left. Okay, and last thing before I end today, acceleration, displacement, and velocity, whenever you're moving down and integrating, make sure you plus C, okay, and you always substitute values from the question to get out the value of C. Okay, if you don't, you're going to lose a value, and you're going to get the question wrong. Okay, and that is the full summary that took 1.5 hours for the whole syllabus. Okay, so these notes here, okay, I'll go and fill up with a little bit more things, especially for the back chapters. Okay, and then I'll post it into the channel after I finish entertaining all the questions. Okay, yeah. So right now I will stop the recording first. So, okay, bye-bye for all those listening on YouTube. How to stop recording.